Hello everyone. So today I'm going to go through a new topic, so please turn to page 46 of your workbook. At any point in time, if you would like to pause the video or you already know what is the answer for a particular question, you may forward the video, okay? Okay, so let's start. Okay, so this particular topic is a mole concept. So before we start, I would like to introduce to you two definitions. What is the first definition? Can you look over here? The first definition is relative atomic mass. So what is relative atomic mass? Okay, I want you to break up into two. The first part is, what is atomic mass? So atomic mass is, in short, if you can look over here, the average mass of one atom. Atomic mass is the average mass of one atom. Now, then why is there the part relative over here? What does the word relative means? If I say that I am older relatively to you guys, what does it mean? I'm older relative to you guys. So it means that I'm older compared to you guys. So the word relative means compared to. So what is the atomic mass compared to? In this case, we compare it to a carbon 12 atom. And you can look at the scale over here. Can you see? So if you look at the scale over here, the atoms are all compared to a carbon atom. So why choose carbon? Why not other elements? Why carbon? Because carbon is stable. Okay, so this is something that you need to know. Okay, in short, let me just break it down, the definition again. Atomic mass represents the mass of an atom. And the word relative means that we are comparing it to a carbon 12 atom. Okay? Can? Now, next. How do I find the relative atomic mass of all these elements? So, there is a mistake over here. Okay, can you please change it? The relative atomic mass of hydrogen is actually 1. Okay, so how do I find all these values over here? You can find all these values in the periodic table. Okay, so if you look at the periodic table, let me just bring you to the periodic table. See. Okay, great. Okay, so where can I find the mass? There, you can see it's over here. So for example, hydrogen, the mass is at the bottom. So this is the mass of hydrogen. How about carbon? Carbon is over here, so the mass is 12. Okay, how about sodium? What is the atomic mass of sodium? So the atomic mass is 23. So we can find the atomic mass of the element from the periodic table. We just have to look at the bottom number. Okay, can? So let me bring it back to the notes again, page 46. Okay, 47. Okay, so you can find the atomic mass from the periodic table, all right? Now, I will just skip some parts over here. Okay, I will just go to the important details. All right, you can read it on your own. Okay, and if they have time, I'll explain it to you next time. Next, how about the definition? Let's look at the second definition. The second definition is relative molecular mass. So let's break it down again. So what does molecular mass means? So previously, if I'm talking about atomic mass, then I'm looking at the average mass of an atom. If I'm talking about molecular mass, then it would be the average mass of a molecule. Okay, similarly, because the definition is relative molecular mass, so it's compared to a particular element. So what element is it compared to? It is compared to a carbon 12 atom. Okay, so let's sum up the two definitions. First, relative atomic mass. Second, relative molecular mass. Okay, so atomic mass is the mass of an atom. Molecular mass is the mass of a molecule. And both of them, they are compared to a carbon atom. Okay? Can? Okay, so how do we calculate molecular mass then? Now, this is how you calculate. So let's say, maybe I need a, let me find a blank space for this, okay? Let's see if I can add, let me just, okay. Alright, let's look over here. Okay, so the atomic mass of carbon from the periodic table, which is over here, the atomic mass of carbon is 12, right? Now, then, if I'm looking at molecular mass, let's just take that the molecular mass of carbon dioxide, because carbon dioxide is a molecule, okay? So how do I calculate the molecular mass of carbon dioxide? So the molecular mass of carbon dioxide is just adding up all the mass of atoms in the molecule. So that makes it 12 plus, what is the mass of oxygen? So let's look at the periodic table. The mass of oxygen will be 16. Okay, so 16. Now, how many oxygen are there? You realize there's 2 oxygen, right? So it is 12 plus 16 plus 16. And the molecular mass will be 44. Okay? So, now what do you realize about all this? Do they have units? Can I say that the atomic mass of carbon is 12 gram and the molecular mass of carbon dioxide is 44 gram? No, okay? There is no units. Why? Because atoms and molecules are too small. Okay? Hence, you cannot say that atomic mass of one atom is 12 gram because 12 gram is pretty heavy, you know. Okay, so you cannot use that. So you can just leave it as, oops, let me just put it back. 12 is a unit of 12. And for carbon dioxide, it's a unit of 40. There's no unit, so it's just 44. Alright? Okay, now let's try again. Let's try another example. Okay, what is the molecular mass of water, H2O? How do you calculate the molecular mass of water? So, how many hydrogen are there? There is 2 hydrogen and 1 oxygen. So, what is the mass of hydrogen? Let's look at the periodic table. The mass of hydrogen is here, right, is 1. Whereas oxygen is 16. So you need a periodic table to do this. So if I have 2 hydrogen, that will be 1 plus 1. And 1 oxygen plus 16. So what is the molecular mass? It's 18. Remember, there is no units. It's just 18. Okay? Now, usually we have a short form for atomic mass and molecular mass. Atomic mass, we will just call it AR. Molecular mass, we will call it MR. So you can write the short form instead of the full word, okay? If not, it's too long. Okay? So let's go back to page 48 of your book. Okay, over here. Now, can you spend the remaining time to do this question? I will try out 2 or 3 questions, and then you can do the rest on your own. Okay, if there is time, I will come by and I'll help you out with these questions. All right. Now, first one, how do we calculate the relative molecular mass of all these substance over here? How do we do that? Okay, so first you need your periodic table and you need your calculator. Okay. Now, so hydrogen, the AR of hydrogen. What is the AR of hydrogen? Look at your periodic table. The AR is 1. Okay, so how many hydrogen are there? There is 2 hydrogen. So what is the molecular mass? The molecular mass of hydrogen is 1 plus 1 equals to 2 because there's 2 hydrogen. Okay, is there units? No, there is no units because one molecule is too small to be measured. Okay, so we just give them a number to it. Okay, next, let's try question 3. Okay, so for question 3, we have AR of carbon because there is a carbon over here, right? So AR of carbon is, refer to your periodic table. You may pause the video if you want to look at your periodic table. So AR of carbon is 12. And AR of hydrogen is 1. So what is the MR of CH4? There will be 1 carbon and 4 hydrogen. So that will be 12 plus 1 plus 1 plus 1 plus 1. And that gives you 16. So if you don't want to write 1 plus 1 plus 1 plus 1, you can also write it as 4 times 1 because there is 4 hydrogen atoms and each hydrogen atom is a mass of 1. Okay? Now, I'm going to try the next one, and the next one is copper 2 nitrate. So the thing about MR, you also need to learn how to break the formula into individual ions. You need to know how many atoms are there in that particular ion. Okay, so let's look at this question. Now, how do we break it up? How many copper, how many nitrogen, and how many oxygen are there? There is 1 copper and there is 1 nitrate and another nitrate. Okay, so I write it in this way. Maybe it's easier to see in this way. 1 copper and 2 nitrate. So each nitrate contains 1 nitrogen and 3 oxygen. So can you tell me how many copper, how many nitrogen, and how many oxygen are there? So that makes it 1 copper, 2 nitrogen, and 6 oxygen. So can you calculate what is the MR? Okay, so let me break it down for you. If you would like to do it on your own, you can pause the video. Okay, you need your periodic table to do this, yeah? So the MR will be equals to 64 because that is the AR of copper plus 2 times 14 because that is the AR of nitrogen plus 6 times 16 because that is the AR of oxygen. So 64, 14 and 16. You have to refer to the periodic table. Okay? That will be copper, nitrogen and oxygen. Okay? And if you add it up, I don't have a calculator with me right now. Okay? If I'm not wrong, the previous class, I think, did this question. It should be 184. Can you all please check that it's 184? Okay? So with that, I will stop here. Now, I will not do all the question, but I will give you a breakdown of all the atoms in the compound. Then you all do it on your own, okay? So remember, you have 1 period to do this, okay? I'll come by if I have the time. Alright, so I'll end the video now.